So I've been looking over all this stuff you sent about managing data in Kubernetes, and it really highlights a kind of fundamental problem, right?
Yeah.
You have this platform that's like perfectly designed for creating and destroying applications quickly.
Yeah.
These like, ephemeral containers,
Right.
which is awesome for scaling and reliability.
Mm-hmm.
But then you've got applications like databases that need to, remember things, that need to
Right.
hold on to data.
Right.
So how do those two things work together? How do you square that circle?
Yeah, that is like the core challenge.
Right.
Kubernetes is so good for these stateless applications
Uh-huh.
where, each instance of the application is basically identical.
Mm-hmm.
And it doesn't really care about holding on to any data locally.
Right.
But stateful applications are like the opposite.
Mm-hmm.
Like their whole purpose is to store and manage data
Exactly.
and make sure that that data is available.
Yeah, and the material you sent, it's like super clear that anything you write to a container's file system,
Right.
it's just gone.
It just disappears, yeah.
Right, the minute that container stops or restarts, it's like poof.
It's like writing on a whiteboard and then wiping it clean.
Exactly.
Okay.
So I think today what we really need to dive into is how Kubernetes solves this.
Okay.
Right, we need to figure out how these stateful applications can actually work reliably in this world of containers that are constantly, popping in and out of existence.
Exactly. Yeah, we need to understand how they can keep that essential data safe and sound.
So let's dig into this concept of persistent volumes.
All right, persistent volumes, or PVs.
All right, PVs.
They're kind of the heroes of the story here.
Okay.
So imagine a PV as like a dedicated chunk of storage capacity that lives within your Kubernetes cluster.
Okay.
Right. And the important thing to remember right from the start is that it's a first-class citizen in the Kubernetes world.
Okay.
It's as important as a node or a pod, and it lives completely independently of any particular pod.
That's interesting. So it's not like tied to a specific application or anything.
Nope, it's completely separate.
Okay.
Which means that your data isn't going to vanish.
Right.
If that pod gets deleted or moved or something happens to it.
Got it.
So Kubernetes creates this like protected space for your data, and it keeps it safe, even if your applications are, doing their usual disappearing act.
That makes a lot of sense. And it's really different from the regular volumes in Kubernetes.
Oh, yeah, definitely.
Right? Because those are tied to the pod's lifespan.
Exactly. When the pod goes, they go.
So it seems like that separate life cycle for the PV is like the key thing.
Yeah, it's the magic ingredient.
Right. Because it guarantees that your data is going to stick around.
Exactly. It's the difference between writing something on a sticky note and carving it into stone.
Okay, I like that analogy.
Right. One is temporary. The other one is meant to last.
And so even if a pod gets deleted or moved to a different machine in the cluster, it crashes or whatever.
Doesn't matter. The data is safe.
The persistent volume just keeps on trucking.
Exactly.
That's awesome.
Right.
So it seems like persistent volumes can work with different types of storage.
Oh, yeah, absolutely.
Right. The stuff you sent mentioned like local disks and NAS and even cloud storage.
Yeah, they're pretty adaptable.
Can you explain how that works a little bit?
Sure. So, whether you're using something like local disks that are physically attached to your servers or a network-attached storage system or even cloud-based storage like AWS or Azure or Google Cloud, the persistent volume basically acts as this middleman.
Okay.
It hides all the complexity of that underlying storage system.
So as a user, I don't need to worry about like IP addresses or anything like that?
No, not at all.
Okay.
You just tell Kubernetes how much storage you need and how you want to access it.
Okay.
And it takes care of the rest.
No. So I can say like, my application needs 500 gigabytes of storage.
Right.
And it needs to be read-write. And Kubernetes will just figure out how to make that happen.
Exactly. And it doesn't matter if it's an Azure disk or a local volume or whatever.
That's exactly cool.
Yeah, it's pretty slick.
So the persistent volume object is like the brains of the operation.
Yeah, you could say that.
It knows all the details about the storage, but it presents this nice, clean interface to the rest of the cluster.
Exactly. It keeps things simple.
So I was looking at this table in the material, and it lays out all the differences between persistent volumes and regular Kubernetes volumes.
Okay.
Can we walk through some of those key distinctions? I think it would be helpful to really understand how they're different.
Sure. So let's start with a basic idea of what each type of volume is for.
Okay.
Regular Kubernetes volumes are usually about sharing data between containers that are in the same pod.
Okay.
Or giving a container some temporary space to work with.
Like scratch space.
Yeah, like a notepad that you can scribble on and then throw away.
Got it.
But their lifespan is tied to the pod. So when the pod goes away, the volume goes with it.
Right, so they're ephemeral.
Exactly, they're temporary.
Okay.
They're limited to that specific pod. And you set them up directly in the pod's configuration.
Okay.
And you're usually working with specific types like empty beer or config map.
Right, so it feels very much like you're just extending the application's runtime a little bit.
Exactly. It's all about the immediate needs of that pod.
Okay, so how do persistent volumes compare?
Well, persistent volumes are all about long-term data storage, right? They live independently of any pod. They keep your data safe no matter what happens to the pods.
Okay.
They're available across your entire Kubernetes environment.
So they're cluster-wide.
Yeah, exactly.
Okay.
And you set them up separately, either by having an admin create them in advance, or by using a dynamic provisioning process. And as we talked about before, they abstract away all the details of the underlying storage.
Okay, so it's a much bigger picture thing.
Yeah, you could say that.
It's not just about a single pod.
Nope, it's about making sure your data is safe and available no matter what.
So if my application's pod suddenly restarts and it's using a regular volume, all that data is just gone.
Yeah, it's like the pod never existed.
But if it's using a persistent volume,
then the data is still there, safe and sound.
So that's the real difference.
Exactly. One is temporary and the other one is meant to last.
And so regular volumes are good for like temporary files or sharing data between containers in a pod?
Right, those kind of short-term needs.
But if you need something that's going to survive no matter what,
then you need a persistent volume.
Okay, that's super clear. So you mentioned two ways to set up these persistent volumes.
Yeah.
Static and dynamic provisioning.
Right.
Can you break those down for me?
Sure. So static provisioning is like the hands-on approach. You have a Kubernetes administrator who goes in and manually creates the persistent volume objects. And when they do that, they specify everything about that storage. Like how big it is, what kind of access it allows, and all the nitty-gritty details about the storage backend.
So it's like a very deliberate process.
Yeah, it's very controlled.
Okay.
But it can be a bit less scalable.
How so?
Well, because someone has to manually create and manage each persistent volume.
Right, it's not automated.
Exactly.
So when would you use static provisioning?
It's often used when you've got storage that's already set up outside of Kubernetes, and you want to bring it into the cluster.
Okay, that makes sense. What about dynamic provisioning? How does that work?
Dynamic provisioning is all about automation.
Okay.
It uses this thing called a storage class.
Okay, I've heard of those.
So think of a storage class as like a template that defines a certain type of storage.
Okay.
You might have a storage class for high-performance SSDs, and another one for regular hard drives, or one for cloud storage.
So you're defining like the different tiers of storage that are available?
Exactly. And each storage class has this thing called a provisioner.
Okay.
Which is basically a piece of software that knows how to create that type of storage on demand.
So when someone needs storage, they don't create a PV directly.
No, they create a persistent volume claim.
A PVC.
Exactly.
And they say what kind of storage they need and how much of it they need.
Exactly.
And they can reference a specific storage class.
Exactly. So they can say, I need 500 gigs of that fancy SSD storage. And Kubernetes will be like, okay, let me talk to the provisioner for that storage class. And the provisioner will go and actually create that storage.
And then link it to the PVC?
Exactly. It all happens automatically.
Well, it's super slick.
Yeah, it makes things so much easier.
So I guess dynamic provisioning is much more scalable.
Oh, yeah, definitely.
Right, because you don't need an admin to manually create every single PV.
Exactly. It's all on demand.
Okay, let's talk about these persistent volume claims a little bit more.
Sure.
They seem like a really important part of this whole process.
They are.
So they basically allow users to request storage.
Exactly.
Right. They're like a shopping list.
Yeah, kind of.
What kind of things can they specify?
Well, they live in the same namespace as the pod that's going to use the storage.
Okay.
So they're specific to that application. And they specify things like how much storage is needed, what kind of access is required, and optionally the name of a storage class.
So if they specify a storage class, that's when dynamic provisioning kicks in.
Exactly.
Okay.
But if they don't specify a storage class, or if you're using static provisioning, then Kubernetes will look for an existing PV that matches the PVC's requirements.
So it tries to find a good fit.
Exactly.
Okay, and then what happens?
Then the PVC is bound to the PV.
Okay, so that's the connection point.
Yeah, it's like saying,
right,
this PVC is now officially using this PV.
So once that binding happens, any pod in that same namespace can use the storage from that PV.
Exactly. It's all connected.
So how does a pod actually access the storage? Like, how does it see it?
So to access the storage, you need to define it as a volume in the pod's configuration.
Okay.
There's this section called spec.volumes. And instead of specifying a particular type of storage, like empty dir or host path, you just reference the name of your persistent volume claim.
So the pod says, I want to use the storage from this PVC.
Exactly.
Okay.
And then there's another part of the configuration called volume mounts. And that's where you specify where the storage should be mounted inside the container.
Okay.
So you could say something like, mount the storage from this PVC at the My Data directory. And then your application can access the storage at that location.
So from the application's perspective, it just looks like a regular directory.
Exactly.
But all the data is actually stored on the persistent volume.
Exactly. It's seamless.
I think it would be helpful to talk a little more about those access modes we touched on earlier.
Okay. Yeah, they're important.
Like, how do they control how pods can use the storage?
So remember, we have ReadWriteOnce, RWO, which means only one pod at a time can write to the volume.
Right. So it's exclusive access.
Exactly. This is perfect for things like databases that need to be the only ones making changes to the data.
Okay.
Then there's ReadOnlyMany,
ROX,
which lets multiple pods read from the volume.
Okay.
But they can't write to it.
So this would be good for, like, shared configuration files.
Exactly. Or static content that doesn't change. Then you have ReadWriteMany,
RWX,
which allows multiple pods to read and write to the volume at the same time.
Okay, that sounds a bit more complicated.
It can be, yeah.
Right, because you have to make sure the application can handle that kind of concurrent access.
Exactly. You need to be careful about how the data is managed.
And then there's ReadWriteOnce COD,
RWOP.
which limits read-write access to a single pod.
Right, but it can be any pod in the cluster.
Okay, so it's not tied to a specific pod.
Nope. It's more flexible than ReadWriteOnce.
Got it. So choosing the right access mode is really important.
Absolutely. It depends on how your application needs to use the storage.
Right. You could end up with data corruption or other problems if you choose the wrong one.
Exactly. So it's something to think carefully about.
Okay, so these persistent volumes have a life cycle, right? They're not just static things.
Yep. They go through different phases.
What are those phases?
So it starts with provisioning,
Okay.
which is where the PV is actually created, either statically or dynamically. Then there's binding, where Kubernetes finds a suitable PV for a PVC and connects them together.
Right, that's the matchmaking stage.
Exactly.
And there's using, which is when a pod is actually using the storage.
And finally, there's reclaiming,
Okay.
which is what happens when the PVC is deleted.
So what happens to the storage when the PVC is deleted?
That depends on the PV's reclaim policy.
Okay, so there are different options.
Yeah, there are three main ones.
Okay, what are they?
So the first one is retain.
Retain.
Which means that when the PVC is deleted, the PV and all the data on it are kept.
Okay.
The PV is marked as released, but it's not automatically available for a new claim.
So it's kind of like putting it in storage?
Yeah, you could say that.
Okay.
An administrator has to manually go in and either delete the PV or reprovision it.
That's a safety net.
Exactly. It prevents accidental data loss.
That's good to have.
Yeah, especially if you're dealing with sensitive data.
What's the second option?
The second option is recycle.
Recycle.
Which is supposed to automatically wipe the data on the PV when the PVC is deleted and make it available for reuse.
So it's like a recycling bin.
Yeah, kind of.
But the materials you sent mentioned that it has some limitations.
Yeah, it's not perfect.
Right.
And it's being phased out in favor of dynamic provisioning and the delete policy.
Okay, so what's a delete policy?
The delete policy is pretty straightforward.
Okay.
When the PVC is deleted, Kubernetes deletes the PV object and also the actual storage in the underlying infrastructure.
So it's gone for good.
Yeah, it's like hitting the delete key on your computer.
Okay, that's pretty final.
It is. So you need to be sure about your data retention policies.
Right, make sure you have backups.
Exactly. Always have backups.
So we've talked about persistent volumes in general, but I'm curious about the actual storage technologies that they can use.
Okay, yeah.
Right, like what are the real-world options?
So if you're running Kubernetes in the cloud, you've got cloud-specific options.
Okay.
Like Elastic Block Store for AWS, Azure Disk for Azure, and Green Persistent Disk for Google Cloud.
So those are kind of the natural choices?
Yeah, they're well integrated and they scale really well.
What about for on-premise deployments?
So for on-premise or more general use cases, you have things like NFS,
Okay.
which lets you use a network file system share.
Right, so that's accessible from multiple nodes.
Exactly.
And then there's ISCSI and FC for connecting to storage arrays.
Right, those are more enterprise options.
And then there's CEFS and RBD, which use the Ceph distributed storage system.
Right, those are good for large-scale deployment.
And then there's local volumes.
Yeah, those use disks that are directly attached to the nodes.
Okay, so that's the simplest option.
It is, but it has some limitations.
Like what?
Well, if a node fails, you lose the storage on that node.
Right, so it's not as resilient.
Exactly.
And then there's host path.
Yes, host path.
Which seems a bit risky.
It can be, yeah.
Right, because it mounts a directory from the host node's file system.
Right, so your pod is directly tied to that specific node.
Okay, so it's not very portable.
No.
And it could be a security risk.
Yeah, it's not ideal for production environments.
So it's more of a development or testing thing.
Exactly.
And then there's CSI,
CS.
which is a newer way to integrate storage.
Yeah, it stands for Container Storage Interface.
Okay.
And it's a standardized way for Kubernetes to talk to different storage providers.
So it's more extensible.
Exactly.
Right, you can plug in different storage systems.
Exactly. It makes Kubernetes much more flexible.
Okay, so it seems like persistent volumes solve a really important problem for Kubernetes.
They do.
Right. They make it possible to run stateful applications. So what are the main benefits of using them?
Well, the biggest benefit is obviously data persistence. Right. PVs make sure that your data is safe,
right,
even if pods are deleted or moved around. So it's essential for anything that needs to keep track of its state.
Exactly.
Like databases or message queues or anything like that.
So it basically makes stateful applications possible in Kubernetes.
Yeah, you could say that.
Okay, what else?
Well, it also improves reliability and data consistency because the storage isn't tied to the pod's lifecycle.
Right, it's much more stable.
Exactly.
Okay.
And then there's flexibility and portability because you can use different storage technologies.
Right.
And you can move your applications around more easily. And it simplifies storage management.
Okay, how so?
Well, administrators can manage the storage at a cluster level, and developers can just request the storage they need through PVCs.
Right, so it's a clean separation of concerns.
Exactly.
Okay, so I'm looking at this diagram that shows how everything fits together. Can you walk me through it?
Sure. So you have the persistent volume, which is the actual storage.
Okay.
Then you have the persistent volume claim, which is the request for storage.
Right.
And Kubernetes matches them up and binds them together. And then a pod can mount the PVC and use the storage from the PV.
So it's like a chain of connections.
Yeah, you could think of it that way.
Okay, so the PV is the storage. The PVC is the claim.
Right.
And the pod uses the storage through the PVC.
Exactly.
That's pretty clear.
Good.
So I think we've covered a lot of ground here.
We have.
Can you just summarize the key takeaways for me?
Sure. So persistent volumes are essential for running stateful applications in Kubernetes. They give you durable storage that outlives the pods, and they provide a bunch of benefits.
Okay.
Like data persistence, reliability, flexibility, and easier storage management.
So they're really important for anyone who's working with stateful applications in Kubernetes.
Absolutely.
Now that we have a better understanding of how Kubernetes handles persistent data, what kind of new applications do you think this opens up?
That's a good question.
Right. Like, what are the possibilities for stateful applications in a cloud-native world?
Yeah, it's definitely worth thinking about.
And I guess it would be helpful to explore the different PV types and storage class options and see what kind of cool things we can build with them.
Yeah, the possibilities are pretty exciting.
Totally.
I think we're just scratching the surface.
I think so, too.
It's going to be interesting to see where this all goes.
Yeah, I can't wait to see what people come up with.
Me neither.